So the things that I want to do today is I want to finish talking about solving trig equations. So for the first chunk of today, I'm not going to introduce any new ideas. What I'm going to do is combine the fact that we have these flowcharts that allow us to solve trig equations with the fact that we can do some algebra. So let's just try doing some of those. In fact, we already have done some. Right, for example, we solved the equation 2 times the square of sine of x minus 5 sine of x plus 2 is equal to 0 by first solving for sine of x, discovering that sine of x had to be one of two things. Each of those two things gave us some simple equations to solve. Let's do something, well, related. Let's try to solve the equation 3 times the sine of x plus 2 is equal to 1. Oh, and I owe one of you a set of notes back. So I think what I even would like to do is say, I don't want to solve this equation, I want you guys to. So I should take a second, solve the equation 3 sine of x plus 2 is equal to 1. As a hint, a good first step is to solve that equation for sine of x. And well, maybe you think that seems unfair. How many people want me to keep talking right now and stuff? Okay. Then I'll talk to it. Those of you who maybe were walking around solving it already have it solved. So let's start with this. 3 times the sine of x plus 2 is equal to 1. For convenience while doing the algebra, I'll make a replacement. I'll just say, well, let's see. I want to solve this for sine of x first anyway. So let's set s to be sine of x. So this equation becomes 3s plus 2 is equal to 1, and I want to solve that for s. What do you need to do if you want to solve that for s?
Subtract 2 from both sides and divide by 3.
Subtract 2 from both sides, divide by 3 will do the job. And let's see. That, I think, winds you up with s is equal to, let's see, 1 minus 2 is minus 1, and then I divided it by 3. Are we pretty happy with that? So I get the equation sine of x is equal to negative 1 over 3. And we have a flowchart that now just tells us how to solve this equation. Either with or without looking at that flowchart, what's the first solution to this equation that you see?
Just add plus 2, or we'll take inverse sign and then add 2 pi k.
So one of the solutions is the inverse sine of negative 1 over 3. And we'll be able to get a general family of solutions by adding a 2 pi k to that. But maybe before we do that, what can we do with that minus sign? We can just pull it up front. So may as well take advantage of the fact that it's odd. Negative sine inverse of positive 1 over 3. So one of our solutions is negative inverse sine of 1 over 3 plus 2 pi k. There's one infinite family of solutions. How do you find the second solution to this?
Subtract from pi.
Subtract that from pi. So our second solution is pi minus this number. So pi minus minus sine inverse of 1 over 3. Is there a simplification you see? Minus a minus is a plus. So the general solution is negative inverse sine of 1 over 3, and pi plus inverse sine of 1 over 3 plus 2 pi k. People feel pretty good about that? All right, so you know how to solve simple trig equations using that flowchart, and you know how to do elementary arithmetic. Just put those two things together. Do you guys think you could solve the equation 5 times the tangent of x plus 2 is equal to 1?
Yes.
Yeah, do it. Once you have an answer, go ahead and compare with those around you. I guess if you're the type that really, really wants to have a decimal approximation, use a machine. Critical mass now of people who have it done. What are the solutions to this equation?
Negative inverse tangent of 1/5 plus pi k.
I hear a negative tangent inverse of positive 1 over 5 plus pi k. How many, well, let's just see a show of hands. How many people will wind up with exactly that? How many people wind up with almost exactly that, but the negative sign is still inside the parentheses? Okay, so everyone who made it there noticed that it was odd and you can simplify. How many people would like to see it talk to it? Okay, cool. Everyone's pretty happy. So let's increase the difficulty by 1 again. Let's get back up to something about this order of difficulty. Let's try to solve the equation 6 times the square of the cosine of x minus 5 times cosine of x plus 1 is equal to 0. So just like before, step 1 is figure out what cosine is. Because once you know what cosine of x is, you can use the flowchart to figure out what x is. So let's rewrite this equation where we'll make it more clear that we want to treat cosine as a variable. So that'll be 6c for cosine minus squared minus 5c plus 1 equals 0. Is that an equation that's easy to solve for c? Yeah, well, in that it's quadratic, so maybe easy isn't the right word, but it's an equation that you have a solution to solve. You have a strategy to solve, whether it's completing a square, or I don't know, trying to factor the thing. I don't know, you're probably using the quadratic formula at this point, and you can do that faster than I can. What values do you get for c?
1/2.
1/2 and?
1/3.
And 1/3. Cool. So now we have two separate equations. Was that too fast? Does anyone want me to linger longer? Okay. You want me to talk through the quadratic formula stuff? Or you want me to just pause? Oh, okay, yeah. Good. Everyone's happy up to here, right? Those are now two simple trig equations, simple in the fact that they're both of the form trig function equals constant. So we have a strategy to solve it. What is the forced solution to cosine of x is equal to a half? Well, it's, on the one hand, it's like inverse cosine of a half, right? Is inverse cosine of a half a number that you know? What is inverse cosine of a half? Or maybe that you know is the wrong one. Is that an x value that you see on the unit circle? What angle does it correspond to?
Pi over 3.
Pi over 3. So our first solution is in fact totally explicit. It's pi over 3. And so our second solution, if you look back to that flowchart, is exactly negative the false solution. So what's the second solution to this equation? Negative pi over 3. And those are like the two solutions you see that happen to live between negative pi and positive pi. If you want them between 0 and 2 pi, instead that should be 2 pi minus pi over 3, but it doesn't matter which one you choose as long as you get two solutions. So now how can you find all the solutions?
Adding 2 pi. Okay.
Add 2 pi's, yeah. So the full solution to the first half of it is x equal to pi over 3 plus 2 pi k, or negative pi over 3 plus 2 pi k. But that's only like half of the job, right? Let's do the same thing for 1/3. And maybe, so how many people feel comfortable even jumping right to what the final answer is? So let's maybe even just talk through it without writing. So what's the forced elementary solution to cosine of x is equal to 1/3? Inverse cosine of a third. And is a third an x value you see on the unit circle? It's not. So there's no simplification to be done. So the next solution is cosine inverse of 1/3 plus 2 pi k. And according to that flowchart, what is the other solution? Yeah, negative this. Cool. Everyone feel pretty good? So let's spend some more time. Let's solve a few more of these equations before we start in on the lecture that I want to be actually associated to today. So, well, here's one. We did a few on the previous page that are of the form some complicated algebra with sine of x involved. Well, what if there's some complicated algebra involving a trig function of something that involves some algebra? Do you think that's still the type of thing we can deal with? Yeah, probably. Let's try to do it. So let's try to solve the equation that 3 times the tangent of 2x minus 1 plus 2 is equal to 1, with parentheses as width. So step 1, figure out what tangent of that stuff is equal to. So let's see. Let's try to solve this equation. 3t plus 2 is equal to 1. And of course, that's already something you know how to solve. What do you get for t? So that means the tangent of 2x minus 1 is equal to negative a thought. So let's deal with the tangent symbol next. That's the next thing on the outside that's done to this quantity. What are the equations to tangent of thing in a box is equal to negative a thought? Well, let's go off to the side and do it. Let's see, tangent of box is equal to negative a thought. Let's try to solve that. What are the solutions to that? Well, what's the elementary solution for that? What's the first thing you should write down?
Box equals inverse tangent of 1/3 negative 1/3.
Box is the same thing as tangent inverse of negative 1/3 is like the elementary solution. When you're thinking about tangent, how do you go from the elementary solution to all the solutions?
Plus pi k.
Because tangent is a very periodic function. And I guess the other simplification, which maybe or maybe not is a simplification, what can you do with that minus sign?
To the outside.
You can put it on the outside of the parentheses. Let's stick a negative sign in front of the tangent and stick a positive sign in front of the thought. So that tells me what the thing in the box is equal to. That tells me that 2x minus 1 is equal to negative inverse tangent of 1/3 plus pi k. Oh, hey, cool. That's just like a linear equation in x now. I have a complicated looking constant over on the right-hand side. In fact, it's a complicated looking infinite family of constants. But that's fine. We know we're going to get infinitely many solutions. This is a trig equation. So what do you need to do to solve that for x? Add 1 to each side and divide by 2. So the right-hand side will be complicated looking, but that's fine. There's nothing to be done about that. So we have 2x minus 1 right now is equal to negative tangent inverse of 1/3 plus pi k. As you already said, you should add 1 to both sides, giving you negative tangent inverse of 1/3 plus pi k plus 1, and then I need to divide both sides by 2. How do people feel about that? Does it seem okay? And you get a complicated looking answer. How do you think you could check if this answer is correct? I don't think I will, but
Use a machine.
you could plug that into a machine. You could evaluate that formula where x is that formula. Let's try to see if we can do one where multiple trig functions are in the formula. Let's try to solve 4 times the cosine of x plus 5 is equal to 4 times the square of the sine of x. So let's see, if this cosine were like a sine, we would know what to do, right? We would rewrite all the sine of x's as s's and use the quadratic formula. If this sine were a cosine, we would also be happy. We would use the quadratic formula to solve for cosine of x, but it's not. But what's an equation which relates sine and cosine?
The Pythagorean identity.
The Pythagorean identity, which says that for any number x, the square of the sine of x plus the cosine of the square of x is always equal to 1. Do you think you could solve that for sine squared of x?
Yes.
Yeah, you just subtract cosine squared from each side. So sine squared of x is equal to 1 minus cosine squared of x. Let's replace that sine squared of x by 1 minus cosine squared of x. What does the equation become now? It becomes 4 cosine x plus 5 is equal to 4 times 1 minus cosine squared of x. How many people, if left to their own devices, would have left those parentheses off? Okay, well, I mean, I do grade your exams, so I know that some of you do. I don't know which ones, but I know that I've seen that mistake. And it would be a mistake, right? You need all of that to be multiplied by 4, not just the 1. Let's distribute the 4, and that'll give us a simplification. We will get 4 times the cosine of x plus 5 is equal to 4 minus 4 times the cosine squared of x. People with me so far? And I know that like all that is supposed to be like down here, but I really figure out the spacing in my PDFs. Cool, so let's take that and try to solve that for cosine. And I don't know, maybe a good first step is let's make it simple onto right. If we just want to solve for cosine first, let's replace the cosine with a c and go from there. So let's replace cosine x by c. Just to make things easier to do, we get 4c plus 5 is equal to 4 minus 4c squared. And I don't know, in some sense I feel like I should just like stop talking and let you guys do, because this is a thing you know how to do. That's an easy equation to solve. How many people want me to keep talking right now about just solving that pulpal equation on the bottom? Okay, good. You guys will walk for a little bit. You will discover what C is. You'll compare your values of C with each other. And once I hear you guys comparing and talking, we'll come back together.
Solution should be -1 and up. See those.
So, there's no need to write that solution twice. There's a single solution with multiplicity too, but I guess that's going to tell me that if we want to graph this thing, it would like bounce off there instead of crossing through the line. That's cool. Now we just need to solve that equation. Maybe before I do that, are people happy? People want me to linger longer on where the -1/2 came from? Okay, good. Let's solve cosine of x is equal to -1/2. And we'll do it exactly as before. What is the first solution you see to that equation? Maybe in terms of inverse trig functions? Negative inverse cosine. Ooh, inverse cosine isn't odd. So, all right, what does the graph of inverse cosine look like? It looks something like that. So it isn't quite odd, so we can't pull the negative sign out like you want to. But there's a different thing we can do. So that's like, what angle gives you an x value of -1/2? And either by consulting the unit circle in front of you or the unit circle in your brain, what's an angle that has cosine equal to negative a half?
2 pi over 3.
2 pi over 3. Nice. So there's the first solution. And notice how like that's not the same as negative the inverse cosine of a half. Okay, so there's an elementary solution to one solution to this equation. Out of that one solution, yeah.
Well, let me just one now. And then once you move the negative 4c squared over to 4c squared is 4c plus 1 equals 0.
Going from there to there.
Yeah, like you would
Yeah, let's do it. I didn't can the answer, so I was just being trusting. Let's go through the walk. So I see a 4c squared. Add that to both sides. Plus 4c. Plus 5 minus 4 is plus 1 equals 0. So there's the equation. And now if you see how to factorize, well, let's just use the quadratic formula and see what happens. So I guess I see c equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a.
I just missed one.
Okay, you lost that?
Yeah.
Okay. Cool. Yeah, so everyone's happy now? So, back down here, one of our solutions was 2 pi over 3. How can you get infinitely many solutions once you know 2 pi over 3 is a solution?
It's 2 pi k.
Add 2 pi k. So that's infinitely many solutions, but it's not all the solutions. We need another infinite family of solutions, and by consulting that flowchart, what is the other infinite family of solutions?
Negative 2 pi over 3 plus 2 pi k.
Yeah. Cool. People feel pretty okay? And you know what the hey? I'm going to be pushed back about a day schedule-wise, but my schedule has space for being pushed back about a day. Let's solve one last one, which is more complicated still because it involves two different trig functions, and those two trig functions are like non-standard trig functions. So let's try to solve that. And so if it only involved one type of trig function, we would be done. It would be easy. But I see two different trig functions. I see tangents and I see secants. And well, maybe a lot of things are spoiled in how it'll go. So let's talk through the strategy. So one idea when things look complicated because there are complicated trig functions is, well, there don't need to be complicated trig functions. If you make the equation more complicated, you can rewrite everything in terms of sines and cosines. So maybe we'll try doing that first. But then we'll have sines and cosines, but maybe we can make it so we like just have sines and just have cosines. We can hope. And once you just have sines or just have cosines, then it's like an algebra game. Then it's what we've been doing. So maybe I'll give you guys a choice. I can cut you guys loose for 5 minutes and to walk, and then we'll come back together. Or I can keep talking. People follow me to keep talking? Oh, good. I keep talking. I like the sound of my voice. So let's do it. Let's re-express everything in terms of sines and cosines. So what is tangent squared of x in terms of sine and cosine? It'll be like sine over cosine, but then all that squared. So it'll be sine squared of x divided by cosine squared of x plus secant. What is secant in terms of sines and cosines? 1 over cosine. And then it'll be squared. So it'll be 1 over cosine squared. And it's still set equal to 1. And then let's just try to muck around and simplify. What simplification would you like to make to that?
Just multiply each side by cosine.
Okay, sure, yeah. Even cosine squared, I think, would be a good idea.
Yeah.
So let's multiply both sides by cosine squared of x. Not the move I was anticipating, but it's a move that'll walk. There's more than one way to do any of these. So let's distribute. I mean, those of you who see why that was a good move know what it'll reduce to anyway. I'll distribute the cosine squared around. Cosine will cancel with the cosine squared. Cosine will cancel with the cosine squared. So the equation will become sine squared of x plus 1 equals cosine squared of x. Everybody happy with that? The move I was anticipating is just rewriting the left-hand side as a single fraction first, but it walks. Nice. So now I see an equation that involves only sines and cosines, is still not too complicated looking. Could I either rewrite that so it just involves sines, or rewrite it so it just involves cosines?
Yes.
Which would you rather, just sines or just cosines?
Just cosines.
I hear a vote for just cosines. Let's see, just cosines? Just sines? I feel like just cosines have it. So that means I want to rewrite all the sines in terms of cosines. So I know for a fact that sine squared of x is the same thing as 1 minus cosine squared of x. So I can rewrite sine squared as 1 minus cosine squared. So I'll replace that sine squared of x by 1 minus cosine squared of x. Plus 1 is equal to cosine squared of x. Cool. And now I guess we simplify fourth line, eventually trying to solve for cosine. So I don't know, I guess 1 plus 1 is 2, and add cosine squared to both sides. 1 plus 1 gives me 2. Add cosine squared to both sides. Very good. So, tell me, what is cosine?
Equals cosine squared of x.
Good. So what's cosine equal to?
Just the root.
Sorry, I heard a cosine of x is equal to 1 already. Am I missing any solutions? Yeah.
How'd you get 2 equals 2 times cosine of x?
Yeah. So let's see. So these parentheses don't actually matter, do they? So really I have 1 minus the square of cosine plus 1 is equal to the square of cosine.
Oh, so just add it over 1 plus 1. Okay.
Yep. Does anyone else want me to talk through that in more detail? Okay. Nice. So now I have two equations, cosine of x is equal to 1 or cosine of x is equal to negative 1. Both of those are like special equations in terms of the flowchart, right? What's the solution to cosine of x is equal to 1?
0.
But I guess plus 2 pi k, right?
Yeah.
And in fact, then who cares about the 0? So x is equal to 2 pi k. And what's the solution to cosine of x is equal to negative 1?
5.
Cool. So I see the solutions to this are in the form an even multiple of pi or an odd multiple of pi. So I'm just going to list them because we could rewrite that as something simpler. So x might be 0 or 2 pi or 4 pi or 6 pi dot 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 Or x might be pi, or 3 pi, plus 5 pi, or 5 pi, or and so on.
Yeah.
So, could you like rearrange these somehow? Like, what's another way of describing that family?
Okay.
It's just all the multiples of pi. Or, simplified, x is equal to any multiple of pi. And I don't know, I alluded to this idea of you should check your answers. Let's just go through the walk of checking the solutions to this equation. So, let's try to check. Ooh. Let's even make it so you can see what I type. So, the original equation was the tangent squared of x plus the secant squared of x, and we wanted it to be equal to 1. And so let's just try plugging in some of our solutions. It's actually up there, right? There was one of the alleged solutions to this equation. Is that equal to 1? And now let's just, I don't know, let's plug in another one of the things in our family. Yeah, that's also 1. And if you wanted to be more rigorous now, you can try some other ones, maybe even in sequence, make sure you don't miss anything. Everything feel pretty good? Cool. So, with 5 minutes remaining, I've already given you the notes that I intended for today. I guess they'll really be tomorrow's notes, but let's start talking about them. So let's talk about trigonometric identities. And maybe we'll even just start by stating an example. What does the Pythagorean identity say? What's the Pythagorean identity?
Secant squared of x plus cosine squared of x. Sine squared of x.
You went sine, right? The other one that starts with an S? There's another one that involves secant, but it's buried deeper in this document.
You knew what I meant. It's Wednesday.
And then I wrote secant. And what does that mean? That means no matter what x value, what angle you evaluate at sine and cosine, that equation will be true. You can't take that equation and solve for x. That equation is true for absolutely every x value. So in general, any equation that's true for absolutely every input you plug in is called an identity. For instance, you know some of these for like logs. You know that the log of a times b is the same thing as the log of a plus the log of b. There are lots of these for trig functions, and let's maybe just recall some of them that we know. Here are some. There are ones that you rewrite in terms of sines and cosines. What's tangent in terms of sines and cosines?
Sine over cosine.
Yeah, so you know that tangent theta is always the same thing as sine theta over cosine theta. You know that cotangent is always theta, cosine theta over sine theta, and so on. You know some even-odd identities. Is cosine even or odd?
Even.
Even. So what's cosine of negative theta the same as?
Cosine of negative theta.
Said an extra negative. The point is the negative sign doesn't matter. It's also true that the cosine of negative theta is equal to the cosine of negative theta, but that's a less exciting fact. Is sine even or odd? Odd. So what's the sine of negative theta the same as? Negative sine theta. And same thing for tangent. Similarly, we have some identities that tell us what happens when you, I don't know, add pi over 2 to things. What's the cosine of theta plus pi over 2?
Negative cosine. Theta.
Not quite. Negative sine theta.
Oh.
And I mean, you can draw a picture of. On the one hand, we did show why that identity is true by studying some right triangles a few weeks ago. The same argument gives us the sine of theta plus pi over 2 is the same thing as the cosine of theta. Tangent of theta plus pi over 2, I guess that has to be the same as negative cotangent theta by thinking about these two. And all of those facts have given us lots of tools that we could use to study trig functions, solve trig equations, do lots of things. So what this document is going to have us think about is how can we take the identities we know, manipulate them a little bit, and prove new trig identities. And I think I don't have enough time to get into anything. So here's what I'll suggest. Think about the things in this document. Maybe even go through and try to figure out the arguments contained. And then we'll talk about these tomorrow. Let's see, so this will push back the schedule somewhat. There's an assignment posted today related to these. And I'll remind you of this also posted to 10 and 1 homework next week. I would like the assignment for today commented separately from the rest of the assignment notes. Because the grading is going to be done differently.
I couldn't use because you emailed me saying that my correction of the test is wrong. Yeah, then I tried to format the test and prove it, and I was gonna do it correctly, but I think that my test is good. So can I go more for tomorrow?
One more.
Yeah, so let me show you exactly what I want, because I want it tomorrow. Tomorrow is the absolute drop deadline.
Yes, alright.
I want you to address the problems. Oh, come on. Midterm. Viewpoint. Ah, there. This to review for midterm 2.
Mm-hmm. And you want me, and I need to do it correctly,
I want you to do all of these problems.
all that ones?
Yes.
Alright, perfect. Alright.